Hi everyone, welcome to the last video lesson of this unit. Okay, so in this lesson you will learn how to graph systems of inequalities. So graph and then name a point in the solution set. So what we need to do again is if we only have y plus 2x is less than or equal to 4, don't forget that this equation needs to be in standard form. I mean, not standard form, slope-intercept form. Okay, so that means I'm going to subtract the 2x's from both sides of the inequality. So then this becomes y is less than or equal to negative 2x plus 4. Then I'm seeing that the y-intercept is 0, 4, so I'm going to plot that point first. So this is 1, 2, 3, 4, plot a point there. Then the slope is negative, and it's got a rise of 2 and a run of 1. So I'm going to drop 1, 2, then overwrite 1. Drop again 1, 2, overwrite 1. Then I'm going to connect the points, but notice this is equal to. Okay, so if it's equal to, that means this line will be solid, a solid line. Which means I'm going to connect the points with a solid line. So then I also have to notice that this inequality symbol is less than, so based on the previous lesson, we shade below the line. Okay, so all of this is below. All right, the next one. This one I'm going to divide by a negative 2 to get the y by itself so that it's in slope-intercept form and I can graph it. So then when we do this, this inequality symbol is going to switch. Okay, so then this becomes y, instead of less than is greater than. This becomes positive x, and then this 6 changes to minus 3. And I'm going to add a note here real quick. And that note is that when you, a reminder, when you divide or multiply by a negative number, switch the inequality symbols. That's what happened here. It used to be less than, we made it greater than because this x, the x went from being negative to being positive. Okay. All right. So then for this one, I'm going to plot the point. The y-intercept is 0, negative 3. So this is 1, 2, 3. Then rise of 1, run of 1, up 1 over 1, up 1 over 1, and I get those 3 points. Then I'm also going to notice that this is not equal to. Okay, which means I cannot do a solid line. So I'm going to do a dotted or dashed line that passes through those 3 points. And I also notice that this is greater than, so that means I'm going to shade above the graph. Okay, so all of this region or area gets shaded, all the area above the graph. And then I notice that there is the double shaded region. This is where we'll find solutions to this system. So I'm going to choose the easy one, which is the origin. Okay, so then I'm going to say solution point or PT. Okay, solution point is the origin. You can choose any of them. As long as the point is in the double shaded region, then that should be a solution to this inequality. So that's all for number 1. Let's move on to the next example. So for the second example, I'm going to keep this with blue. There's a negative 4 in front of this y, so I'm going to divide by negative 4 each one of these terms. So then this is now y. Now notice this is going from negative to positive, which means you switch the inequality symbol to less than instead of greater than. And now we have 2 over 4 simplifies to 1 over 2. So 1/2 x, and 4 divided by negative 4 is minus 1. Okay, so I'm going to plot 3 points and then sketch the graph for this one. So y-intercept of 0, negative 1, plot a point there, then up 1 over 2. Okay, then up 1 over 2 again, and that should be enough points. Then I'm also noticing that it's not equal to, so I'm going to draw the graph with a dotted or dashed line. So once I've sketched the line, I look at the inequality symbol. This is less than, so then I'm going to shade below the line. Okay, so all of this region gets shaded. And then let's do the other one. This one is already in slope-intercept form. So the y-intercept is 0, 5. 1, 2, 3, 4, 5. Plot a point there. Rise of 1, run of 2. So from here, up 1 over 2. Up 1 over 2. And this one is not equal to either. So then I'm going to connect those 3 points with a dotted line or dashed line. So there is the line. Now notice this is greater than, so that means all of this area above the graph gets shaded. So as you can see, the shades do not intersect. So then for this one, we say this system has no solution because there is no region in which the shading of the two equations or inequalities intersect. So this system has no solution. So let's move on to the last example. Notice in the last example, we have 3 inequalities. Okay, so, and they are all, so this one is slope-intercept form and slope-intercept form. This one is just a horizontal line. So let's start with, I'm going to do this one with blue. So then y-intercept of 0, 4, 1, 2, 3, 4, plot a point, rise of 1, run of 4. So up 1 over 4, up 1 over 4, and that should be enough. Point. It's equal to, so that means this line is solid. So there we have the line of the first inequality. The second inequality, we have an absolute value. Okay, so then for this one, plus 2 inside of the absolute value means we go left 2. So 1, 2, plot a point. Then a is 1, which means just like the slope of line, up 1 over 1, or left 1, up 1, right, left 2, up 2, right 1, up 1, right 2, up 2. And this is also equal to, so let's connect the points with the V, which will give us a V-shaped graph. So there is a graph of the absolute value. The last one I'm going to do with green. So this will be green, and this one is the red one, the second inequality. So for this one, y equals 1, so that's here. Okay, so for any value of x, y will always be 1. So it's just a horizontal line because the slope is 0. And it's also solid. So I'm going to just draw a line of y equals 1. And now I'm going to go back and shade. So first notice that the blue line, it's less than, right? So then all of this region is shaded anywhere below the line. Okay, so all of this region gets shaded. And then the absolute value, this is greater than, so that means all of this area gets shaded. Oh, and I went overboard here. So anywhere above the V-shaped graph gets shaded. Okay, then the last one, which is the green line, which you can barely tell. Okay, this one is greater than or equal to 1, so that means all of this region gets shaded. So then we need to choose a point in which the graph has solutions. So I'm going to choose the point, let's see, this is -2 up, let's say right there. -2, comma 2. So then I'm going to say the point, the solution point, okay, solution PT for point is the point -2, comma 2. But any point you choose in the triple shaded region is a solution to that this system of inequalities. Okay, so that's all for this lesson. Thank you for watching. Bye-bye.